Thank you for downloading this podcast from Talk Radio 702 and 567 Cape Talk. For more podcasts and more information on your number one news and talk station, please visit 702.co.za or capetalk.co.za.
Leaders say 2 years old and making a difference.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Riddy Clappy.
Chris, good morning.
Morning.
Lovely to be chatting to you again. Let's start with the Sumatra quakes. Major changes taking place as a result on the ocean floor, that is?
Yes, potentially. There's a paper in Nature this week. It's by Professor Delacluse from Paris. And they've been looking at the patterns of tremors that have occurred, because if you look at the news stories that have gone on over the last 10 years or so, we've seen a succession of extremely large quakes, including the one that caused the Boxing Day tsunami in 2004. There was another very large earthquake in April of this year. And their theory, or their proposal, they're modelling how these movements could be explained and what may be happening and why they're escalating. They suggest that actually the plate there, which is both the Australian plate and the Indonesian plate, they're suggesting that this tectonic plate mass could be actually splitting. So instead of having just a plate boundary, we're going to get some new plates formed. But it's not going to happen soon, though. Probably over the course of a few million years yet. So don't hold your breath, but we could see some new tectonic plates. So human geologists of the future may have to slightly change their tectonic map of the Earth's surface.
Okay, and all of the quake, of course, happened in April earlier this year. Thank you very much, Chris. All right, our lines are open for you on 021-446-0567, 011-883-0702. We are taking your SMSs as well on 31702 and 31567. Chris, I've got an SMS here. I'll spell the word out because I can't pronounce it. John in Germiston called in about a POMPHOLYX on his ankle, called last week, and wanted to know, what's the question? I just wanted to know what this is. Can the Naked Scientist please explain?
Yeah, this was the question about Pomphalix. And Pomphalix is an eczematous condition, and I said, I'm not a dermatologist, so what I'd like to do is go and find one and ask, because John's specific query was, how can you treat this rather than just slap steroids onto it? So what I've done for him is I went to the Professor of Dermatology at the University of Manchester. His name is Chris Griffiths, and I asked him to answer the question, and I've got it here.
Well, Pomphalix is a form of eczema that occurs predominantly on the palms and the soles. There does seem to be some link to stress exacerbation, and treatment can be difficult. It depends if one gets the underlying cause. Steroids are one of the better treatments, I have to say, and that's true for a lot of inflammatory skin diseases. Other treatments which have been used successfully are local ultraviolet light treatment, either plain ultraviolet B or something called PUVA, which is psoralen ultraviolet A. So psoralen is a photosensitizer, which is you can put into an aqueous solution, and the patient can put their hands in there, soak their hands in there for a while, and then have UVA irradiation, and that does help quite markedly. And then there's other treatments such as cyclosporine, which of course is a systemic immunosuppressant. So I suppose the bottom line is that we don't know a lot about it. It's definitely a recognized clinical entity, and it's felt to fall into the atopic dermatitis or atopic eczema spectrum. But there are some people, though, who develop this as a consequence of contact allergy. So it's, in some extent, it's maybe not a specific disease entity, but more a clinical sign of eczema or eczematous reaction on the palms, where you don't get the sort of scaling and redness that you'd see with ordinary eczema because of the thickness of the epidermis, and you get these little blisters forming in the skin.
So an eczematous reaction on the hands and feet, classically often on the soles, and as Chris Griffiths says, steroids is usually the mainstay, but there are some other treatments that can be used for more dramatic and more troubling examples of this.
Thank you very much for all this trouble, Chris. And John, there's your answer. Thanks for the question last week. So our lines are open for you. What do you want to know? 021-446-0567, 011-883-0702, 31702, your SMS line if you are in Gauteng, and 31567 in Cape Town. Let's go to Jackie in Florida, Joburg. Hi.
Hi, Reedy. Good morning, Chris. How come when you suntan you get blisters?
Hello, Jackie. Well, hopefully you don't suntan and get blisters too often, because if you're getting blisters, this is actually a burn. And when you are out in the sun, ultraviolet radiation, which Chris Griffiths was just referring to, is damaging to skin. And the damage, if it's mild, triggers the skin to increase the amount of melanin, the dark pigment that is in the skin. If the damage is more severe, then it actually physically kills or destroys skin tissue and causes a local spot of inflammation, a hot spot, if you excuse the pun. And that hot spot releases all kinds of inflammatory chemicals, and this leads to the immune system moving in, and blood vessels open up, water from the blood vessels filters out, cells filter out, and you get a collection of fluid, which is the extracellular or tissue fluid forming, and it coalesces into a little bleb under the skin, and that is the blister. So when you have blistered, you have done quite serious damage to the skin, and that probably should serve as a lesson. You have to be a bit more careful in future, so put on some sun cream and stay out of the strongest sun.
Okay, Jackie, do take care of yourself, especially at this time of the year. We have an SMS here from William. William asks, if water is tasteless, why does boiled water taste different from unboiled water?
Yes, what an interesting question. I'd never really thought about it. Hello, William. The situation here is that although water, when it comes out of the tap, we regard it as pure water, it's anything but, because there is enormous amounts of dissolved ions and salts in the water. There are also dissolved gases like oxygen and a bit of carbon dioxide. When you boil water, what you do is often remove a lot of those dissolved gases, because hot water can't carry as high a concentration of dissolved gas as cold water. So when the water is boiled, you will drive off some of the dissolved gases. And some of those ions and salts include things like temporary hardness, calcium bicarbonate, CaHCO3 twice. And when you heat up the water, these I suppose you could say these salts or these compounds are unstable, and they decompose under the high temperature, and calcium bicarbonate, CaHCO3 twice, becomes calcium carbonate, chalk, all over the elements of your kettle or in your geyser. And as a result, you are removing some salts from the water, and therefore you're changing its composition. So although the water hasn't changed terribly much by being boiled, the things that are dissolved in it will have changed, and this can subtly affect the chemistry of the water, and that could contribute to a flavour difference. Also, when you boil it, it's possible that other things that are already loitering in the kettle could move into the water, and that could change the flavour too. I remember I was on a camping trip once, and we made some tea with someone's camping kettle, and it was one of those kettles that doesn't have a lid. You just fill it up through the spout. And what we hadn't realised is that there was some really quite nasty fungus growing in this thing, because when we made the tea, it really didn't taste too good. We had a look in the kettle, and there was a big wodge of it was a half a mushroom forest growing in there, and that's why the tea tasted funny. So that's another explanation.
Okay, let's go to Roland in Rustenburg. Hi.
Good morning.
Yes.
Good morning, Chris. Chris, I recently got into discussion with some engineers, and we were talking about how everything is specialized nowadays. And the one mentioned that in today's age, there's nobody able to make a simple pencil from scratch.
Pencil?
You know, the person, yes, the person wouldn't know how to mine the graphite, then bind it, make it into the pencil, and then the person wouldn't know how to make, let's say, the brass to hold a little rubber, or a single person wouldn't know all these things. Is that correct?
Well, I guess what you're asking is there one person that is so skilled that they could do all those different jobs in today's world? And the answer is probably very few. I agree with you. In the old days, we had real polymaths, or at least the engineering equivalent, people who really could turn their hand to anything. These days, the world has become extremely specialised. The pieces of equipment that we all use in our day-to-day lives and we all regard as essential, a mobile phone, for example, there is no way one single individual could have all of the skill set necessary to build that piece of apparatus. So you're probably right that we've become so specialised that actually there is no way that one person working alone could do all the things that we just regard as absolutely essential to our daily lives now. And that change has happened over a dramatically short timescale, hasn't it? I mean, if you think, just in my lifetime, we've seen computers become mainstream in homes. We've seen the internet come along. In my grandparents' lifetime, we've seen everyone going from driving around in horses and carts to everyone owning a car, certainly in Western countries. And so it's a very interesting transition that we've seen, and the pace of change has become incredibly fast, and with it comes high-end engineering that is not the preserve of individuals anymore. You're absolutely right.
That's fascinating. Perhaps we should discuss that in greater details with the trend setters and the people who often come on the show to make projections about how our world will look like in future. Thank you, Roland, for that interesting question. Christine, James, Jenny, I see you. Coming back in a moment.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Riddy Clappy.
Let's go to Jenny in Observatory. Hi.
I'm making bottled goods, and once the goods are in the bottle, I fill it up with the sugar syrup. The sugar syrup, there's always some left over, and I wanted to know, A, why it doesn't freeze, and B, whether I can reuse it.
Hello, Jenny. What are you putting into the bottles, out of interest?
Little mandarin oranges.
Oh, I bet they're tasty.
They're wonderful. Come to Cape Town and I'll give you some.
No, I'll take you up on that. I shall hold you to it.
Sure.
So you're doing this with sucrose, the stuff like granulated sugar. You just make a very strong solution of that. Yeah.
Yes.
Well, the reason it doesn't freeze is the same reason that if you make a really strong solution of salty water, it doesn't freeze. And this is because when water as a liquid is made very cold, the water molecules, which are shaped like little boomerangs, have to get into a certain configuration where one molecule is arranged relative to another molecule in order for it to form the lattice that is an ice crystal. And if you have a very strong solution of sugar, that means that there are lots of molecules of sugar in amongst all of the water molecules. And in the same way that if you're making a model out of building blocks or something, and you have some funny shaped ones that you have to incorporate, the whole shape of the model goes wrong. And in simple terms, if you've got these giant sugar molecules sitting there, they get in the way of making this ice lattice, and the crystals can't form properly, and so you have to make the temperature much lower before it will begin to freeze. It will still freeze, but it will take a lot lower temperature to do it. Because of the energetics of how these particles get in the way. And it's exactly the same way that antifreeze that you would put in your car engine to stop the radiator freezing up in certainly cold countries, but in wintertime, that's exactly the same principle. These molecules stop the ice crystals forming in an organised way to make a big ice crystal, unless you make the temperature correspondingly a lot lower.
Thank you very much, Jenny. And Christine in Linwood Ridge. James, I'm coming to you in a moment. Christine, hi.
Hi. I wanted to find out why my dog always yawns. I've been sitting down with her or lying down. The minute I stand up, she yawns.
Oh, no, your line is really, really bad, Christine. But I understand you want to ask, why does the dog always yawn when she gets up?
I haven't the foggiest. I'm really sorry. I mean, it might be a learned behaviour, but I really don't know. Does any dog behaviouralists who are listening know about this? Why should dogs want to yawn when they get up? Most people yawn when they want to go to bed, but I don't know the answer. I'm sorry, Jenny.
Thomas doesn't yawn when he wants to go to bed. He yawns now. Thomas, do you want to go to bed? I just saw you yawning now. No,
well, that's a sympathetic yawn, isn't it? So as soon as someone starts talking about yawning, or they see people yawning, you have these sympathetic yawns, and that's actually a physiological response. We think that yawning is really infectious because it's a way of keeping you alert.
The funniest thing I saw, Chris, was someone yawning was during the Comrades Marathon, which is 89.6 kilometers, and you're basically running the whole day if you're not one of the runners who compete. And I saw a guy who just pulled over to the side of the road and he was sitting on the pavement and just yawning. But he did finish the race. He did start running at some point, but he was sitting there yawning.
Did he have a little snooze at the side of the race then?
I've known runners who do that. They just sleep for 10 minutes and then get back because it's a whole day affair. Okay, so So anyone knows why dogs yawn when they get up, please let us know. We'd love to get that answer. Let's go to James in Fishhook. Hi.
Oh, good morning. Hi. It's been shown that a family who generations ago suffered in a famine carry an impaired gene, which can be seen by scientists today. Could you expand on the implications of that for all our pollution at the moment and things like that?
Hello, James. I think you're referring to a study. There's been a number of studies, but there was a paper that was published in 2008 by a guy in the Netherlands, and I think his name's Bas Heijmans, and he was looking at the Dutch hunger famine. During the Nazi occupation of the Netherlands in World War II, certain parts of the country were starved, and amongst the people who were being starved because they couldn't get the food in and out were women who were pregnant at the time. Now, a number of those women survived, and their babies survived, and those babies are now 60 years old. And doctors have followed their health, and they've shown that these individuals who were starved when their mothers were starving at the end of the war have a higher risk of heart disease and diabetes and stroke and high blood pressure and obesity compared with their brothers and sisters who were born at a time when they weren't being starved. And this has led them to conclude, because those groups are all individually very closely related to each other, the only difference being that one of them was developing with a very, very poor supply of calories compared with the others. Is there something that's going on epigenetically, or in other words, is there something changing which can be inherited, which is related to how genes are turned on or off? And what Bas Heijmans points out in his paper, they were looking at a gene called IGF-1, insulin-like growth factor 1, and he found that in these individuals that were being starved when they were developing in the womb, a certain gene had a different pattern of chemicals stuck to it, which changes its activity compared with the individual's brothers and sisters. And this epigenetic modification is a reflection on that fairly harsh environment those individuals were growing up in. And it looks like that trait could be heritable. And so this is the whole science of epigenetics, which is an emerging science now. We're realizing that it's not just what's written into the genes that's important, it's how those genes are turned on and off. And these chemical markers that can be stuck onto the side of the DNA to control the activity of genes are at the root of this. And so this is really a very important field which we're beginning to understand more of now, and it probably does have enormous implications for the world we live in. In other words, you make the point, the pollution we're exposed to, well, that too could have impacts on us epigenetically. It could change the way genes are turned on or off, and that could in turn have implications for our health. So it's a very important question.
Thank you, James. Let's go to Herman in Houghton. You're a doctor and you've got an answer for the dog yawning question.
Yes, good morning. I'm a neurosurgeon. I don't know about dogs, but I believe it would be the same reason as in humans. You know that the speed at which your brainwaves run are grouped into classes alpha, beta, theta, and delta. And when you are in an alpha mind state, your brain waves are going at a slower rate than when you're in a beta mind state. Now, yawning occurs when a person passes from one state into the other. That is why when you before you go to sleep, you're slowing down from beta into alpha and then into delta. And at those transitions, you yawn. When you wake up, you yawn because you're going from delta into alpha or from alpha into beta. And why that happens, I don't know, but apparently the yawning is a marker of changing from one mind state or one of those bands into another, which is also why when people get bored, for instance, they go from beta down into alpha, which is the meditation or hypnosis state, and then they yawn.
Okay. Naked scientist?
The only thing I'd say, Herman, is interesting theory, but we wake up every day, we go to sleep every day, at least when we're alive, and when we're not listening to 702, because that gets everyone going. But of course, the thing is, we're doing this regularly, but we don't all yawn. I certainly didn't yawn before I went to bed and went to sleep last night. I haven't yawned yet today until I had the intense sensation to yawn when Reedy started talking about it. And I think that actually, whilst your point may be relevant to what's going on in the brain, that change may actually be more a reflection of another process. And there was a paper published from a guy called Gordon Gallup in New York at the State University of New York. This was in 2006-07. And they found that brain cooling is a way of blocking yawning. And they showed students lots of videos of people yawning and totted up how many times the students yawned in sympathy. And then they asked them to hold a cold compress on the front of their head and watch the same videos again. And the sympathetic yawning rate went from about 100% to 0. Then they asked them to just breathe through their mouth rather than through their noses. And this has the reverse effect. It does not cool the head as much, and the yawning rate went to high levels again, compared with breathing through the nose. So his theory is that actually you yawn when your brain temperature escalates, because certain drugs which escalate brain blood flow and raise temperature will increase yawning. Fatigue, which raises brain blood flow and increases brain temperature, causes yawning. And their argument is, therefore, it's a way of increasing your alertness, and it's infectious, because if one person's nodding off, it's likely another person could be nodding off. So if you make everyone yawn, cool the brain, increase alertness, everyone wakes up, less likely to be preyed upon by a wild animal.
All right, Herman, thank you very much.
Thank you very much. I didn't know that, Chris. Thank you.
Very
Bye-bye.
interesting. Thanks indeed. Chris, we've loved chatting to you. And I must just tell you, everywhere I go, whether it's a shopping mall or a party, people talk about the show, but they're talking about The Naked Scientist. So we really appreciate you giving us 30 minutes in your busy schedule, Chris.
Well, thanks for having me, everybody. It's lovely to talk to you too, and thanks for the great questions. We get the best questions from around the world from 702, I think.
Stunning. I love that. Of course, we will podcast this conversation. Bye, Chris.
Bye-bye. Take care, everyone.
Bye. And yes, you can go to the website and download the Naked Scientist podcast.